So in this presentation, we're going to cover the following topics: basically the grid interconnection process, which is the basic reason why we decided to develop this tool, the features of this connection tool that we propose, and some more details about the inner workings of it, including things like database manager and grid placeholder, which for now may not be very familiar to you. And then we're going to also cover the typical roles of all the actors involved in this, let's say, project. We're going to start with the description of grid interconnection process. So it is not a secret that we need to develop generation plant models, and they must comply with grid codes, as many presentations today have already discussed, including the one like a couple of seconds ago. And the way to demonstrate that the model complies with the grid code is by presenting test results. It can be relatively big list of things like single phase faults, three phase faults, step tests of reactive power, active power, frequency deviation, so on and so on. The list is long, and each system operator has their own list. And when a model developer presents such results to the system operator, usually it's done with a relatively small equivalent of the grid. So quite often it's going to be a Thevenin equivalent with certain voltage source and, let's say, smallest, weakest possible grid at the point of interconnection. It is a way to, let's say, perform the simulations relatively fast. You don't have the whole grid, but also it doesn't have a lot of details. So you present your grid at basically one operating point, but there could be many other things. There are other IBRs included in your system. There could be interaction between them, so you cannot really see anything of this while doing such tests. So if you want to add anything to this?
Yes.
Okay. Second step in this process is, let's say, the system operator perspective. The system operators typically have their own EMT models, but they do not want to share them with anybody else because they want to have it, very, very secret, very precious, very confidential. And because of this, they need to perform a lot of tests themselves once they receive a model from a, let's say, manufacturer of the generation owner. Why? Well, because there are many more things you can see when you perform simulations with the whole model of your grid. And it quite often happens that once you start doing such tests, there are new things that come up, new problems, so the model has to be adjusted. Then the model goes back to the generation owner. They spend around some time, months maybe, to update it. The model goes back to the system operator. They perform the same test. They discover new things, new problems, and so on and so forth. There's a lot of back and forth, and it's a very time-consuming process.
All right. In this part, we have a lot of experience dealing with the asset owners, not only generation, because we're also seeing the upcoming transmission projects that need to be tested in this platform. But the cycle that Anton just mentioned is critical. And just to give you a little bit of context, in 2022, we released this directive from the operator that everybody should comply with EMT models, and we choose 3 years ago that should be based on EMTB. This was arbitrary, but we need to decide one of them, or one of the existing ones. And for us, back then, it was more attractive to go with EMTB, so we stuck to it. But later, we found out that we need to integrate to our big power grid model around 600 models. And the upcoming models that need to be connected to the grid. So we're not even ready. The department that takes all this volume of work is not ready to take this work and catch up at any point with 600 models in the next 10 years. So we needed this kind of tool to accelerate that process, and at some point to start asking for the model as a condition before entering into operation. Because right now, we want to do it, but it's not possible because we can't handle the work. This tool reduces these times of cycling with the asset owners, because most of the time they don't know what to comply with, even though we have this big document that tells everything that it's very like outlaid. What are the requirements for the model? But it's not clear enough. At least we see that now that it's not clear enough. But when we get the model, we started to see that there are very common issues, like what was the equivalent they used, what was the time step they used, what was the initialization process they used. So these conditions, and as there are 600 models, we started to answer every asset owner with the people we have. We are 7 people in my team, and this is only taking like a year or 2 years to tell the asset owner that all the process was full of mistakes. Yeah, we needed something that could streamline the whole situation. And the other thing is that as they use equivalent models for the deliveries they gave us, they don't have access to the whole power grid. And it's full of confidential information from different asset owners that were already accepted to be integrated into this model. And it's not that we don't want to share the information, because we're not owners of the information, but we want to give incentives to the providers of the models, I mean the providers of technology, that we're not sharing, that we're protecting their intellectual property. So this would create like a very positive conditions for them to give us, to give away their models and trust us that we're not sharing it with anyone. So this is more like a commitment to the market that the chilling operator is not filtering, it's not leaking the information. This is more to give a message. So yeah, this is the intention of on our side for the tool.
Okay, so with all these problems and issues in mind, we propose the following tool, which we call EMT Connection Tool or EMT Online Connection Tool. It is a web portal that allows to integrate the models of asset owners with the models of the grid that are, let's say, developed by system operators, and perform simulations online without user intervention, with a large degree of scalability. So if the system owner, the system operator prepares, I don't know, 100 different scenarios, 100 different cases, the asset owner can connect their model and perform all the 100 simulations automatically without directly intervening in this process, and then just get the results and analyze them. So in this way, since everything is handled automatically, there is very little problems related to confidentiality, because the asset owners, they do not have access to the grid because it's just online. They don't have access to the, let's say, background, the back end of this. And the system operators, they just know that okay, this generation owner performed the tests, and once the model is ready, they will get and use it. So it is a new product that we are offering to everybody, but for now we have been focused on working with the Chilean system operator, CN, and RT as well. So a couple of words about the overview of the process, how it all works. So the first step in the process is for the system operator to prepare and upload the designs to the platform. Let's say certain versions of the grid in, let's say, 2030, with different load levels, different, I don't know, faults in mind, N-1 contingencies in mind. Once this is done, the project is prepared, then the asset owner can prepare their own model and upload it online. Once it's done, This portal creates a virtual machine with the EMTP installation on it, gets the required files from the storage, connects the asset model to the grid design, performs local dynamic simulations, and then shares the simulation results with the asset owner that launched this process by uploading their model. Once it's done, the virtual machine is destroyed, and we're back to, let's say, the initial operating point. This is a more schematic overview of different players that are involved in the process. So we have the TSO, the generation or asset owner, and the online portal. So the system operator needs to do two things: generate many different grid configurations and also prepare what we call a grid placeholder. This is a specific device that we're going to cover a bit later in the presentation that allows the asset owners to, let's say, connect to the grid in their designs. And then everything is connected in the portal, the designs are merged, create virtual machines, run simulations, and share the results. Okay, a couple of words about the tools that are used to facilitate all this process. So for the system operator, this database management toolbox allows to facilitate the process of creating different versions of the grid, different scenarios. We're using what we call a database file. It's essentially the same as a regular EMTP design, but we decided to change the extension to DBF as a database file to make it distinct from regular designs, so for, let's say, improved user experience. In this file, when you open this file in EMTP, you can generate regular designs files, depending on the settings that you provide in the GUI. You export the designs in a certain folder, and each design comes with a set of parameters, such as the metadata, grid configuration, different load scenario, different contingency. So we have in mind that these three variables are a good set to represent the grid and its condition. Then with each file come two additional ones: the list of buses to which the asset owners can theoretically be connected to, because you don't necessarily want all buses be available to the asset owners. They have access only to one. And here is the list of the ones that are allowed. And the JSON with the metadata configuration that we just covered here. And so each design, of course, comes with certain dependencies, as Simon was mentioning previously. Well, there are already a lot of existing models, and they usually require DLLs or some parameter files. So quite often there will be a lot of dependencies as well. So all of them are also exported.
Well, like Anton said, this is the user. You can call it GUI. Well, part of it is an interface for us to control the amount of scenarios we're preparing for each market participant. It eases up for us the generation of scenarios, because in this particular project of the HPDC preliminary, we need to run around between 100 and 150 simulations. And take into consideration that our simulation system takes 24 hours to run 20 seconds. So it's like if it were only one machine, it would take several months to run it all. And the amount of scenarios also that need to be set up for all of these contingencies are different. It's not 108, but it's, I don't know, maybe 20 scenarios. And we need to have control over the information we make available for the market participants in order for them to run specific contingency on the specific scenario. For instance, if we program the HPDC to run a full rated power, but he connects half rated power, the system would shut down. So we need to be careful with that. And this tool that EMTP developed for us was very easy to work a lot.
Next up is the other toolbox that is used to facilitate this process. This is what we call a grid placeholder. So this is something, it's a device in EMTP that has to be created by the system operator and be given to the asset owner for their designs. So this component represents the grid of the system operator in the designs of asset owners. It's basically an empty sub-circuit, but it has a mask that allows to select the required configuration of the grid. So there are different versions, different scenarios, contingencies that are pre-programmed, and the users, the asset owners basically have to select what kind of configuration they want, and everything will be parameterized accordingly. So this device contains a single or multiple three-phase buses, depending on what kind of project it is. If it's a simple, let's say IBR that has only one connection point, okay, it's going to be one bus. If it's an HVDC, it needs likely at least two buses. And depending on the project, maybe you may have even more requirements for buses. All right, so with these things cleared, now we can describe the basic operation from the system operator perspective and from the asset owner perspective. The typical TSO actions on this platform are going to be as follows. They need to create and upload the grid models, which we have covered previously. So there are different scenarios, contingencies, etc. For different projects, you also can reuse the same designs. So let's say if you have your version of the grid prepared for 2030, you can reuse the same scenarios and designs for, let's say, connecting another IBR, another PV, another HVDC link. This allows to accelerate again the process of interconnection studies. Then once all the designs are ready, you create the project. On the platform, you assign the asset owner or generation owner, as we have in this presentation. You say which grids, which designs are linked to the project, which buses the asset owner has access to. And once this is done, the system operator needs to create the grid placeholder and share it with the asset owner.
This part of the platform is very intuitive. It doesn't have many options. The idea was to restrict the freedom, the degree of freedom for the user. I'm going back to using user because in this case, we tried the platform with three testers. Was two consultants and one university utility. So they gave us their feedback, and we realized that it was ready for work. But it was because it was very transparent. All the information was there. We could handle each user on separate. Also, we needed to present demos for the platform because this is very new. Not only because of the platform, but because of EMTP is 11 new in Chile. Still, after 7 years maybe. But people are getting more familiarized with the terms, with the using of this platform, the certain terminology like grid placeholder maybe it doesn't ring any bell, but that it represents a point of connection in the system is also something that they need to take in at some point and starting using it correctly. Like I said, but as Anthony shown in this slide, it's very simple. It doesn't have many steps, and it's not very heavy. Also, it's a very lightweight database that is created out of the big power grid. Also for us as the operator that manages the system, and also for the user that only couples or connects their models into this grid placeholder.
And then a couple of words about the perspective of the asset owner, generation owner. This is also basically a three-step process, just as for the system operators. So the first step, of course, is to prepare the model. And this step may take some time, but it is the prerequisite to be able to start using this connection tool platform. Once the model has been established, you then connect it to the grid placeholder device that is supposed to be shared with the asset owner by the transmission system operator. And then for each, let's say, test that you want to do, you have to parameterize correctly the settings in the mask of the grid placeholder. So once you prepare, let's say, your list of designs, you can upload them on the platform. You can upload one or multiple at the same time. Once you do it, the virtual machines are created and we start all the simulations all together. And once the simulation is over, basically the only next step is to download the results and perform analysis offline. So this is a relatively straightforward procedure.
When you upload the design, the grid placeholder is replaced by the actual grid.
Yeah, it's a good comment, exactly. So this device, the grid placeholder, exists only until the moment where you upload it. So once this asset owner design is taken, is uploaded to the platform, the grid placeholder is replaced by the actual grid that was created by the system operators, and it's connected automatically to it and perform load solve without domain.
One of the challenges here is the initialization process of the asset owner model. Because as the administrator of the scenarios or the power grid model, configure the system to run at a certain power, output power of this particular model, maybe it's a PP model, he needs, the user needs to not only comply, but needs to use these parameters, like the initial power. If even if it's configured to run at this initial power, but it takes, for let's say, a second or 10 seconds sometimes to only reach steady state, it's too much, it's too long. So also it's a challenge to communicate to the industry that they need to follow certain procedures to model correctly the assets. Hopefully it would initialize before 2 cycles, right? But yeah, sometimes they put so much detail into the model, for example, the HVDC project, that it's taken the real time that the actual asset takes for it to start. So yeah, a lot of things need to be taken into consideration before connecting it properly, and that the results are valid afterwards.
Well, I guess this concludes our presentations. So thank you for your attention, and we're going to welcome your questions.